In this video, we're going to have a second look at the AsyncTask class. Now in this video, we're not going to do the same as the previous one, but what I want to do is to show you how to place the AsyncTask now in its own class. And if the AsyncTask is in its own class, it means that we can use that class also outside of the main activity and everywhere we want. And it's also a bit more structured, which means that if there's something wrong with the background process, I can just go to that one class and make the changes I need. I don't need to go into the main activity and search where it is. So it's a lot more structured. So let's see how we can do something like that. So I'm going to create a new class for my AsyncTask. But before we do that, let's just go through on what I have currently. So I created a new project called AsyncTask Template Video. And this is my main activity. So it's basically a progress bar at the top. So how do you get your progress bar? Just go to that search at the top. Start typing progress, and you can see there's your two progress bars. So I've dragged in the horizontal progress bar as the first element, then a simple button and a text view. So if you look at your button, it's just the text do something in background. This text view is called TV results. This button is called BTN do, and your progress bar is called progress bar. And then in the main activity, what I've done is I've declared those three components. I've linked those three components with the find view by ID. And I've set the progress bar's visibility to gone, which means the user won't see it when the application starts. And then there's the on-click listener for the button, which we'll get to later on. All right, so it's just a few basics for what we're going to start with. So let's go into our package there. And what I can do now is to go and right-click on the package and say New Package. And I can go and add, let's say, for example, database DB operations. And then say OK, and I can have all my database operations in there. And what I can also do is to go to say new package and say, let's say all activities, and say OK. And I can then drag in my main activity there, say refactor, and now all my activities is under this one, and all my database operations will be, for example, under this package. Now this is just an example. I'm not going to do any database related stuff today, just to show you that we can actually structure our classes a bit so it makes more sense on where am I. Okay, so under DB operations, I'm going to right click and say new Java class. And this class, we're going to call whatever we want to call our async task. So I'm going to say run something in the background. So obviously you will have something specific on what you want to do. And yes, it must be a class, and you're going to say, okay. So there's the beginning of my async task class by just saying extends, and we're going to say async task. Now there's the generic types again, params, progress, and result. So for the types there, if you don't want to accept anything, you can just use the void keyword there. And let's say void, void. And for the last one, we'll accept a string, or we'll basically pass back a string. So remember, your first data type is what are you going to pass in? What is the type of the data you pass into your async task? So I'm just not going to pass anything there. For this example, let's just pass in an integer there. And I'm not going to use a progress bar, which I'm going to update the whole time. So you'll see on my activity main XML, I've set my progress bar to its indeterminate value there to true, which means I'm not going to update the progress the whole time. Okay, and then if you're done with those three generic values, then use Alt-Enter, implement methods, and the one method it must have is the do in background. You remember from the previous video. Let's just open up this one. So let's just get those methods again. The first one there, we can generate, go to override methods, it's the on pre-execute method. So that one runs in the user interface thread. I'm not going to use the progress update, so the last method I need here will be the on post execute. Right, so this is the most basic version of your async task, and you can see it will run, obviously for the first time you run this, it will go into on pre-execute, then go into do in background method, and then go to on post execute. So let's say we will do something here that will get a result, and then we will say something like this is the result. Right, so now let's say we want to return then results. There we go. We can return this results, and then this results gets returned back there. So now it depends on what you want to do with this whole situation. Let's say we just want to want to show a toast here. And you can see the first problem we get here is that it doesn't pick up a context here. And that's the first thing. You can't pass in this because an async task isn't a context. The context is basically an activity and services and stuff that runs. And most of the time you're going to use either an activity or you're going to get the application context. And even from here, I can't call get application context. I can't call get activity. I cannot use the context here. And this is the problem we're sitting with if your async task class is in a different class. So what we do then to overcome this problem is that we can go, just remove this. We can go there at the top and we can go and declare, and I'm going to only use it inside of this class. I'm going to declare it private, and we're going to say context and get some context passed in. Automatically it's going to cry about this because it says this field leaks a context object, and you can go and read a bit about the context. But basically what happens here is if you pass in or you use a context variable here, I'm going to talk about the context now. Let's just see how we can create also a constructor for this class. So there's a default constructor that basically executes every time you use it, but you can also indicate a constructor for this. So I'm going to say public run something in the background. That's the constructor. And we can accept that context. I'm going to explain this context now. So then when we start running this async task class, we can pass in a context, and then we can set our context, which is this dot context, we can set to the context that was passed in. Now then that will allow me to go then down and show a toast by calling context there, because that context is the context where we're going to show it. And then we can say just print out, or we can say results, and then print out that S. And if we run it now, it will actually work. So let me just quickly explain this now when we call it inside of the main activity. So let's go to the main activity. How do we call this run something in the background now? So it will be the same as previously. You're going to say new run something in the background. You can see it picks it up. And then you can see this is now the constructor. So previously we just said .execute there, and we passed nothing into the constructor there. So that's the constructor, and it needs the context. So what I can pass in here is not the this keyword, because this refers to this on-click listener. So if I want to pass in the main activity as the context, you're going to say main activity.this. So now the main activity is the context that we're passing in. So that context gets passed into this constructor, and we're setting that context to this context. And now this thing is crying because it says it leaks a context. So what happens with sometimes with these async tasks is that while you're busy with the main activity, you run something like download a big file or whatever in the async task, because it runs on a different thread, which is allowed. You do something there, and then this part in the background takes a really long time. Such a long time that your main activity gets cancelled at some point, and or gets removed from the foreground where the user don't see it anymore. And then what should happen is that your main activity will be marked for garbage collection so that it can free up memory for your phone. And now, because it's still linked to this async task, the context is still linked to it, the garbage collector cannot destroy this activity, which means now there's what they say here, a memory leak in your application, which will slow down the phone at the end. So that is what we do not want. So when we pass in the context there, I would rather not pass in the context, but on that context call get application context, which means that you are passing in the application context and you're not linking it to a specific activity. So on the activity, I can call the get application context, which will get me the application context, which is the global one. And I'm passing in that context, which means that even if my main activity gets destroyed, or if it wants to destroy my main activity, it can, because it's not linked to the async task. So what is getting linked now? It's the application itself. It's basically the application class that gets linked to this, which means that only when the application gets destroyed will this be a problem. Okay, so at this stage, yes, it's fine that it says there's a leak there. But if we just make sure that we pass in the application context, then that will actually not be a very big problem. Okay, so now we pass in the context. So the context has been set, and now that toast can show. So let's run this quickly. Right, so if we click on do something in background, you can see it says results. This is the result. But now how do I set the text on that text view now? Because now this is in a totally different class, and I need to set something, let's say, for that text view now. So it says the results, this is the result. So that's fine. It's using the application context to show that toast, which is 100% fine. But we need something more here in order to communicate back to my main activity. So for this, I'm going to create an interface. So let's go into DB operations, and we're going to create a new Java class, but indicate an interface there. And let's call this interface AsyncTask Callback. And then we're going to say OK there. Now this is my interface, and I basically want to have only two methods here. So I'm going to have one method, void handle response. And this handle response will now, because my do in background method returns a result there, which is a string, I'm going to have that as some sort of string that we're going to return there. And let's just call it object. And then I'm going to also say void handle fault. And that fault will be in the form of an exception. And I'm going to show you how we're going to do that exception now. So remember that for this async callback, you can also use a generic type there. So you can use, let's say, for example, a T there. And instead of passing a string back, you can pass in any type of object. So just remember that you can use the generic type there if you don't know what that object will be. And then ultimately, when this method gets called, that object you can convert to the specific object that you obviously know it is linked to. So I'm not going to use generics right now. So I'm going to keep this one a string so that we return back a string from this callback. Right, so let's go back to the async task. And what I want to do here now is to use that exception. So remember, we're going to pass back a string, and we want this exception to also return back if there's something that went wrong inside of the background. So that context is fine. Let's have another private variable there, and I'm going to call this an async task callback. So this is now the type of my interface, and I'm going to call it callback. Then also I'm going to need the exception message there, and let's call this one exception as well. Now in the constructor, I'm going to accept here this callback. So it's going to be the async task callback, and let's call it callback as well. And then I'm going to set my own callback here. So I'm going to refer to it by saying this.callback equals then this callback that was passed in. Right, so I'm going to show you now how this interface works. So I'm going to have an instance of the interface there, basically. Actually, the activity that is implementing this interface will then be passed in here. But I'll show you different ways on how you can do this. So I'm passing in that callback there, which will be a link to some implementation of the interface. And we're going to have a link to it. Now, because we have a link to it, somewhere along the line, there's the exception also. So I'm actually not going to use the on pre-execute, but you can do something there if needed. So what I'm going to do here is to set up this exception message here, and I'm going to set the exception to null. So what we can do then as a template for future work is we can run a try and a catch block here, passing in that exception. And then instead of putting that results or whatever you want to do, you're going to do everything you want to do inside of this try block. And then when the exception occurs, we're going to say the exception should be equal, this exception E that occurs must be equal to the exception that we have. So then when we return then the results there, and I'm going to set results also there at the top quickly. So let's do it like this. Let's just set it as something, and then we can return results there. So if the results doesn't change, it will be like this. Otherwise, it will say this is the result. If there's an exception, that exception will be saved into our exception variable that we called right at the top. So what are we returning? Still just a string value. So I'm going to remove this toast now. So what we're going to do here is to first test here if that callback, our callback, is not equal to null. So we make sure that it is actually connected so that we can use those methods of the callback or of that interface. So if it's not equal to null, then I'm first going to check if the exception is equal to null. What does that mean? So if exception is equal to null, like it is assigned there, it means that there's no exception that took place. So which means everything went fine. And you can see there's two methods, handle response and handle fault. Handle response for everything went fine. Handle fault, there was an exception that occurred. Okay, so this is what we're going to do. Let's go back to this one. If the exception is null, which means that there was no exception that occurred, then we're going to use that callback to call handle response because everything went fine. And then I'm going to pass in the S there. So remember, this one accepts a string. Okay, so handle response accepts the string, but if there was a fault that happened, I'm going to call the handle fault method. And this handle fault method, we're going to pass in this exception message of ours. So exception will then be, if it's not null, it means that it's been set there. Some sort of exception occurred. And that's the exception that we pass through to the handle fault method. And you can see handle fault accepts an exception. So this I'm going to use as a base for future programs that we're going to create. So let's just have a quick look at this implementation again. So we're going to have the context at the top, the callback for the interface, and then some sort of exception there. We're going to have a constructor that accepts the context, and make sure that this context that you pass in is the application context. Do not pass in main activity.this. You could sit with a big problem there. And then your second one there is the interface callback. So I'm passing in type of interface there, and I'm setting my callback to that. I'm setting my context to it. So after the constructor, it will run on pre-execute. Nothing will happen there, or we can do something there in the future. And then it will run the doing background method. There we set the exception to null and whatever we want to do there. And then we try whatever we want to run in the background. We're not actually doing something in the background now. We're going to use this as a template. And then we catch the exception. So if there's an exception that occurred by doing something in the try block, then we will set that exception to our exception variable. And then ultimately we're going to either return this results, and that will be nothing, or it will return the results. And in any case, testing for it here. So this return will go back to that one. And when it returns, when it goes into on post execute, we know that the background is done. So then we test if the callback is still fine, and the exception message is null, which means that there is no exception, or not the message, the exception object is referring to null. Then we know that there was no exception that occurred. Everything went fine. And then we call using this callback that was passed in that one, which is now set to our callback, which is of type interface there. We're going to call that interface method called handle response, passing in that result. If there's an exception, which means the exception is not equal to null, we will call handle fault and pass through the exception. So now this is all fine for this class, but how do we implement this now in the main activity? So it's also not that difficult. We can go and say for the second argument now, so the first argument's fine. It is get application context. So now there's a second argument that we must pass in. And the second argument there is now basically what? It's this part. Okay, so there's a few ways on how you can do this. You can go to your main activity and say implements that async task callback. And then you alt enter on it, implement methods, and say okay, and it will create the two methods, handle response and handle fault. Okay, so then what I pass in here will just be main activity dot this, which means my main activity will handle these two methods when they come through. So this is going to run in the background, and when it's done, it will run either handle response or handle fault, and you can do your coding, what you want to do right in there. Okay, so that's one way of doing it. So I'm going to remove this because this is not a very good way to do it. So I'm going to remove it. So another way to do this is to go and create a new callback. So I'm going to say AsyncTask callback, let's call it callback, equals new. And now if you say new, you can see it creates like this line type of class with its methods. So what I can do then is to pass in as a callback this variable. Sorry about that. Let's just say callback. Pass in this variable called callback, which means that it's going to run in the background, and as soon as it's done with running in the background, it will call either handle response or handle fault, and it will go into this part for handle response and handle fault. So that's another way of doing it. Quite nice way to do it, but the best way to do it will be to say, not even putting the callback there, but just say new AsyncTask callback, click enter, and it creates everything for you. So in one line of coding, basically, we have going into the background and then calling that or using this interface with its two methods where it will automatically pop into handle response or handle fault, depending on what happened. Okay, so now if we have handle response here and handle fault there, we can now decide what are we going to do when that happens. So obviously we've got TV results there. So if the handle response method runs, we know that everything went fine, and we're going to go to TV results and just set the text to this object that was passed in, which is called object there. Now, where does this come from now? So this method handle response will run when we're done in the background, results will be set to this as result. The exception is not null, and we call handle response, passing in S. What is S? It is what is getting returned from your doing background method, which will be this is the result. Okay, so that's the method. So that part will say this is the result if everything went fine. And we set that to the results. And we can even show a toast from here because we're in the main activity or normal activity, and we can say something like process done. And then just before this, we're going to call this progress bar of ours. So we're going to say progress bar dot set visibility, and we're going to say view dot visible, so that the progress bar will start showing just before we call this. And then where do we stop showing it? Well, you need to stop showing it in both methods, both there and here. So if there's a fault, you don't want to have that progress showing anymore. So you're going to say gone there, and also when it's done in the background, everything went fine, we're also going to stop showing it. So you start showing it just before you call your async task, and then inside of both of those two methods, you need to stop showing it. So we're going to show the toast, and then we set the visibility to gone. Now in the handle fault, we can just show a toast for the user there, and we can say something like error e.getMessage. So now where does this e come from again? So let's say it goes into the background. This line of coding throws an exception. It will go and set the exception that is thrown to my exception object, and that exception will then, here it will evaluate to false, and it will go and it will call handle fault, passing in that exception. And in that exception now, I can go and call e.getMessage. Right, so in the handle fault, if something went wrong, we're just going to show the error and then stop showing the progress bar. But if everything went fine, we set the text to the TV results, we say that the process is done, and we set the progress bar to gone. Okay, so I hope you understand this part. I'm going to use this exact same concept in the following few videos, where we're going to look at the Room API and how we can store data in an SQLite database. So it's very important also in SQLite database that we work on a different thread when working with the data in the database, so that we don't slow down the user interface. So it's very important that you go through this and make sure that you understand this concept of the async task in its own class and how we pass in the context, and as well as using interfaces to link back to my main activity, or basically any activity that wants to use the database operations. So this is now the nice thing. You can see it's sorted under DB operations, and we're going to have callbacks there, and we're going to have the async task that doing different things in the background. So make sure that you understand this concept. This is very, very important, and you can see how we can use these async task now that's in its own class, which means I can use it now in any one of my activities. I don't need to copy and paste the whole time. I can start using this. So it's code reuse. I can use this again in any one of my activities. Just very important to note that this context will show you that it leaks a context object, but if you run some memory software on your phone to check your application, or You get some memory applications or libraries that you can include in your Java or Android applications that will test if there's a leak. So the way I'm doing it right now, there's absolutely no leak. And why is that? Because I'm not sending through just the activity. If I would send through this main activity.this, yes, there would be a leak because this async task is then connected to my main activity. But at the same time, also this async task will run for such a short amount of time that you will probably also not get a memory leak. So the best way here is to go and say get application context. So there can't be a leak on the main activity. So let's run this application quickly just to see how it runs, although it's not really doing anything, but you can see that everything should be fine and we should see some text on the text view. Do something in background, this is the result, process done, 100% fine. No problems, no exceptions that occur. So what you can try and do there is to see if you can do something there in this part that could throw an exception, and then you can also test that out. Right, this will then be used as a template for future videos, so please make sure that you understand this concept. Hope you've learned a lot. See you in the next one.